In this video, we'll be discussing about class 9th second chapter is matter around us pure. We all know what is matter. Matter means anything which has mass and can occupy space is known as matter. Is all matter pure around us? Let's see in this chapter. See, matter can be classified as two pure substances and mixtures. Okay, matter is classified as pure substances and mixtures. What is meant by pure substance? Pure substance means it consists of only one type of atoms or particles. Pure substances are made up of only one type of atoms or particles is known as pure substance. Example for pure substance are elements and compounds. Elements and compounds are example of pure substances. What are elements? Elements are the substances made up of only one type of atom. Example, metals. Metals will come under elements. Example for compounds. See, compounds means these are the substances made up of two or more atoms in definite proportion. See, compounds made up of two or more type of atoms in definite proportion. That is called compounds. Atoms combined in the compounds are in definite proportion. That is why they are considered as pure substance. Example, water molecule. Water molecule is a compound which comes under pure substance. In the water molecule, 2 hydrogen and 1 oxygen atom is present. Yes, next is mixtures. See, mixtures means it is a combination of different substances into each other to form mixtures. See, in the mixtures we can see different types of atoms or substances mix each other. Example, salt solution, sand and water. Salt solution, sand and water are the example for mixtures. Next, types of mixtures. Mixtures are classified into two types: homogeneous mixtures and heterogeneous mixtures. Mixtures are classified as two categories: homogeneous mixtures and heterogeneous mixture. See, example for homogeneous mixtures is solutions. Solutions are examples of homogeneous mixtures. Heterogeneous mixture, suspensions and colloids. See, what is meant by homogeneous mixture? Homo means same. Here, when you mix solute particles in a solvent, it look like single substance. It look like single substance. That is known as homogeneous mixtures. When it comes to heterogeneous, hetero means different. See here, solvent and solution, solvent and solute particles look different. Okay, they do not mix uniformly. They do not seem like same substance. They look different. Okay, that is known as homogeneous mixtures and heterogeneous mixtures. In case of homogeneous, the whole mixture look like single substance. Whole mixture look like same substance. But here in heterogeneous, it has different layers, and heterogeneous mixtures we can easily identify solute and solvent. Example for homogeneous mixtures, salt solution, salt plus water. Salt solution. See, when you mix salt into the water, we cannot make out salt particles in the solution. Salt particles will dissolve uniformly. It dissolves completely in the solvent. What about heterogeneous mixtures? Heterogeneous mixtures will form two layers. Example, sand plus water and oil and water. See, in case of oil and water, we can see two layers, one layer of oil and one layer of water. And sand and water, in case of sand and water also, we can see sand particles settle down in the water. So, these are called heterogeneous mixtures. Here, salt plus water are called homogeneous mixtures. Next is difference between homogeneous and heterogeneous mixtures. Homogeneous mixtures, see, they have uniform composition throughout the solutions, throughout the mixtures. That means if you add salt into the water, salt will not deposit only on the top of the solvent, or it will not settle only at the bottom of the solvent. Salt will mix uniformly in the solvent. We cannot see salt deposition only at one place in the solvent. It dissolves uniformly. In case of heterogeneous mixtures, we don't see uniform composition. That means solute particles will not dissolve uniformly in the heterogeneous mixtures. Example, oil and water. See, if you pour oil into the water, it will settle only on the top of the water. It will not mix thoroughly in the water. Next point, see, these homogeneous mixtures have single phase. That means one layer. Okay, see, for example, salt and water. If you mix salt into the water, we can see single layer, isn't it? We don't see two layers. That is known as single phase. In case of heterogeneous, mixtures have two or more phases. Mixtures have two or more different phases. Again, example, oil and water. We can see two different layers in case of oil and water. And also sand and water. We can see sand will deposit it at the bottom of water. These are the difference between homogeneous and heterogeneous mixtures. Next is solutions. What are solutions? Solutions are homogeneous mixtures. Here are different types of solutions. Liquid solutions. Example, water and ink. Then water and acetone. These are the examples of liquid solutions. Solid solutions. Example, alloys. What is meant by alloys? Alloys means it is a homogeneous mixture of metals or metals and non-metals. Next is gas liquid solutions. Example, dissolved carbon dioxide in water or dissolved oxygen in water. This is an example for gas liquid solution. Next, solid liquid solution. This we have seen in our common examples. So sugar plus water and salt plus water are the examples of solid liquid solutions. These are the different types of solutions. Solutions are made up of two components, solutes and solvents. Let's see what are solvents and solutes. Solvent means the substance which dissolves solute particles in it is known as solvent. So always solvent is in a greater quantity. That means it is in a larger quantity in the solutions. Example, water. Water is a universal solvent. It dissolves solute particles in it. So always solvent quantity is greater than solute particles. Next, what is solute? It is a substance which get dissolved in the solvent is known as solute. For example, salt or sugar. Salt and sugar are the examples of solute particles. The quantity of solute is always less in the solution compared to solvent quantity. Solvent concentration, always concentration of solute is lesser in the solution. Now let's see properties of solutions. First property, solutions are homogeneous mixture. Solution is a homogeneous mixture. Second property, particles cannot be seen through naked eyes. Particles of a solution cannot be seen through a naked eyes because particle size is very less than 1 nanometer. Less than 1 nanometer. So we cannot see particles through our naked eyes. Particles means particles of solute. Solute particles cannot be seen through the naked eyes. Next property, see when you pass a beam of light through our solutions, we cannot see the path of light. Path of light cannot be seen through our solutions because as particle size is very less, they cannot scatter beam of light pass through the solutions. Understood? Next property, we cannot separate solute particles from solution by filtration. By simple filtration, we cannot separate solute particles from the solution because as again size smaller, as a size of solute particles is very smaller, they can pass through filter paper. We cannot separate solute particles by filtration. These are the properties of solution. Next class we'll study about different types of solutions and how to find concentration of solutions. Thanks for watching. Please do like, share and subscribe to my channel.